It is time for another test, the end of Chapter 9, so here is a test review. Okay, so try to find these probabilities, this one when you flip a coin, and these ones when you roll a number cube. Press play when you're ready. Alrighty, now for the first one, when you flip a coin, one side is tails out of two sides, so your probability of getting tails is 1/2. With the number cube, there's one side that has a 4 on it out of 6 possible outcomes, 6 different numbers, so we have 1/6 of that. For even, there are 3 even numbers, 2, 4, and 6. Out of the 6 sides on a number cube, don't forget to reduce that fraction, so we get 1/2. Right here, probability of getting a 2, 3, or 5, those are 3 numbers that are going to make me happy out of the 6 possible numbers, and that reduces to 1/2. And for this one, the probability of not 1 or 2. Well, the numbers that are not 1 or 2 on a number cube are 3, 4, 5, and 6. That's 4 numbers out of 6, which reduces to 2/3. Alrighty, take a look at another question. Okay, so if you have blocks with the following letters, and that's 10 blocks total, go ahead and find these probabilities. Press play when you're ready. Okay, so 1 block is A out of 10 blocks. The probability of getting A is therefore 1/10. There are 3 blocks that would be labeled C out of 10, so the probability of getting that is 3/10. This one says the probability of not F. Well, 2 of them are F. That means 8 of them are not F, so it's 8 out of 10. Don't forget to reduce that to 4/5. Right here, probability of B or C. 1 B, 3 C's. That means that's 4 blocks out of 10, and that reduces to 2/5. All right, let's check out the next question. Okay, if there's a 40% chance of snow, what is the complement, and what is the probability of the complement? Okay, remember, the complement is the opposite, so the complement of snow is no snow. Do not put a number here. If you say 60% for the complement, it's wrong. The complement's no snow. The probability of the complement is 60%. These are complementary events. That means that either one or the other has to happen, 100% chance of snow or no snow. So when you add these two probabilities, they should always add up to 100%. All right, let's take a look at the next question. Okay, so read over this scenario and press play whenever you're ready. All right, so remember, theoretical probability is what you think will happen, not what actually happens when you do the experiment. Remember, the first 2 letters, TH, first 2 letters in think, TH. So theoretical probability of getting 6 is what you think will happen when you roll a number cube, and you should have a chance 1 out of 6 of getting a 6, because there's 1/6 out of 6 sides. Experimental probability is from the scenario. Experimental probability of getting a 6, well, it said it landed on 6 3 times, so we have 3/10. Theoretical probability of getting 1, again, 1 out of 6. Experimental probability from the scenario, it landed on 1 twice out of 10 rolls, and 2 out of 10 reduces to 1/5. Do not forget to reduce your fraction. Let's take a look at the next one. Okay, so last year, 120 out of 300 people ordered pickles at a store. So how many people would you expect this year out of 500 to order pickles? Go ahead and try this problem. Press play when you're ready. Okay, so 120 out of 300 last year ordered pickles. So we want to know how many out of 500 this year should we expect to order pickles. So remember, we solved these problems with cross products. So 300 times x equals 120 times 500. 120 times 500, that's 60,000. So we have 300x equals 60,000. Divide both sides by 300. That cancels, leaving x. And 60,000 divided by 300 is 200. So we would expect 200 people out of the 500 to order pickles. All right, let's check out the next question. Okay, so draw a tree diagram in sample space. If at a store, first you get to choose small or large, and then second you get to choose no grease, greasy, or wow, that's a lot of grease. Okay, so with your tree diagram, here we have our first set of choices, small or large. Here we have our second set of choices, no grease, grease, or wow, that's a lot of grease. Sample space right here, you can get a small no grease, small wow, large no grease, large grease, and large wow. Now, let's try to answer the questions. So what's the probability of a small no grease, of a large, and of a wow? So there's only one small no grease out of the 6 possibilities, so we'd say this probability is 1/6. For the large, there's 3 larges out of the 6, so this probability would be 3 out of 6, which reduces to 1/2. And for the wow, there's a small wow and a large wow, so that's 2 out of 6, which reduces to 1/3. All right, let's take a look at the next question. Okay, this is a fundamental counting principle problem. 5 types of pasta times 3 sauces times 3 sizes. That means we would have 45 outcomes or 45 combinations. So if you drew a tree diagram and made the sample space, your sample space would have 45 combinations there. Fundamental counting principle lets us get this right away without drawing the tree diagram. Okay, if a student rolls a number cube and flips 3 coins, how many outcomes are there, and what is the probability that they'll get a 3, then tails, then tails, then heads? Give it a shot. Press play when you're ready. Okay, well, if you roll a number cube, there's 6 possibilities, 1, 2, 3, 4, 5, or 6. When you flip a coin, you can get heads or tails. Same for coin 2 and coin 3. Multiply those all together, fundamental counting principle, and we end up with 48 possible outcomes. Now, the chance that someone's going to get a 3, then tails, then tails, then heads, that's 1 outcome or 1 combination out of all 48. So if you drew a tree diagram in the sample space, this would be 1 of the 48 items in your sample space. So 1 out of 48 is the probability. All right, let's take a look at some more questions. Okay, try these 3. Press play when you're ready. Okay, so if 4 students are lining up for a picture, all 4 of them, they're going to line up. So you start with the number 4, and you have 4 factors. So this is permutation 4, 4. So we have 4 times 3 times 2 times 1, and we end up with 24. If 6 people are in a race, how many ways can the runners come in first, second, or third? So we have 6 runners in the race, and we only care about the first 3 positions. So permutation 6, 3, start with 6, 3 factors, 1, 2, 3, and we always go down by 1. 6 times 5 times 4 is 120, and this was not a word problem. Permutation of 8, 3, start with 8, times 7, times 6, we end up with 336. Okay, let's get ready for the next question. All right, so in a fruit bowl, you've got 2 apples and 3 pears. So if the student's going to take a piece of fruit, eat it, then grab another one, as long as they're doing this randomly, what's the probability that they would grab an apple and then an apple? And then if they had a whole brand new fruit bowl, same scenario, what's the probability they would grab a pear, then an apple? Press play when you think you have it. Alrighty, so in this scenario, when the person first reaches in, there are 2 apples out of 5 pieces of fruit. Now once they take one and eat it, there's only 4 pieces of fruit left in there. So the second time they reach for an apple, there's 1 apple left. Remember, they ate one already. 1 apple left and only 4 pieces of fruit in the basket. You multiply both of these probabilities together, you end up with 2 over 20, which reduces to 1/10. In this situation, we start over again, a new bowl of fruit. There are 3 pears out of 5 pieces of fruit. Take the pear out, eat it, reach in for an apple. There are 2 apples, but only 4 pieces of fruit. 3 times 2 is 6, 5 times 4 is 20. 6 over 20 reduces to 3 over 10. Now, if you have all this, no problem. You should be in good shape for the test. It might be a good idea to take a look at my mid-chapter review video as well for some extra problems on the first half of this chapter. All right, see you tomorrow, boys and girls. Good luck.